Hello, Mr. Champika. You can start share your slide.
Okay, thank you. Do you see my slides?
Yes, we can see.
Is it on full screen now?
Yes, full screen.
Okay, thank you very much, Ms. Kind. And also, thank you to all the participants for joining this session. Good morning. And so to introduce myself, I'm Champika from ICANN. ICANN, I think probably you may have heard about ICANN before because we have done some sessions during previous MMNOG events as well. So my focus during this session is going to be on DNSSEC and why you should be adding DNSSEC as a security mechanism into your cybersecurity strategy in your organizations. So that's what I'm highlighting in this presentation. So let us go into a little bit more details. If you are in the DNS operations, you're probably already familiar with this concept. But in case if you are not into DNS operations, it is worthwhile to understand how DNS queries work or what are the important components in DNS. So you can see here that we have, I hope that you can see my mouse pointer. So we have clients or resolvers, stub resolvers. Usually, you could be having a device or your laptop or whatever, mobile phone. And in your device, you have a stub resolver. And that would do API calls with your applications that you're using. So if you say, for example, if you want to browse a certain website, your stub resolver will need to provide the IP address of that web server to the application. So it would send a query to a recursive resolver. And usually these recursive resolvers are operated by the service providers, ISPs, mobile operators. There are public DNS servers as well. Also, there are sometimes your organization might be providing you the resolver service. So there are various bodies, organizations who run these recursive resolvers. So the query goes to a recursive resolver. Sometimes we also call this as a caching server or recursive server. And then this recursive resolver would send the query to what we call authoritative name servers. So there are many types of authoritative name servers. As you may know, DNS is a hierarchical namespace. It's a hierarchical database. Top of the DNS hierarchy, we have what we call the root. And then we have top-level domains, second-level domains, and so on. So there are many root servers scattered around the world. And ICANN, as an organization, we also manage root servers as well. They are called ICANN Managed Root Servers. And then there are top-level domain servers. So now from Myanmar's perspective, there is .mm. So root has delegated .mm to Myanmar registry. And then .mm can do further delegations to anything .mm. So you see the hierarchy here, and whoever the parties in this hierarchy is responsible for a certain namespace, they have to run what we call an authoritative name server, because they are authorized to authorized for that namespace, and they are authorized to run the name servers for that. So this is where we are running primary name servers and secondary name servers. Now, so root servers are authoritative name servers for the root zone. And similarly, .mm name servers, they are authorized for the MM zone. So there are about 5 authoritative name servers for .mm, and they are scattered in different networks. So they run the MM space, or they keep the MM space. So anyway, as we explained earlier, the recursive resolvers that is run by ISPs, mobile operators, public DNS servers, and so on, they send queries to these authoritative name servers and get the response based on the authoritative name server and find the answer, and the answer is returned back to the client. So this answer is kept in the caches of the recursive resolver for future queries, so that the response time would be much faster. So that's how a typical DNS query works. I won't go into too much detail here because our objective is to talk about DNSSEC. So I hope that this operation is clear to you. So every day, every time when we use the internet, we do so much of DNS queries behind the scene. So even if you visit a web page, or even if you open your mobile apps, when you send emails and things like that, always, DNS work behind the scenes. And so that's how a DNS query gets resolved. Now, let's try to understand the problems we have in this whole process. So the client would send a query to a server. Say this client would send a query to it could be a DNS server, right? And then the DNS server would respond. So that is our expectation. But in reality, another server can impersonate this server. Impersonate means it can act like this server, right? So this server, you can see the one in red it could be a server that is managed by or operated by an attacker, right? Or a miscreant who send an evil response to the client with a wrong answer. So if you want to visit your bank website, right? If you want to, as a client, if you want to visit your bank website, the query goes to a recursive resolver, just like what we explained before, and then go through the root, the TLDs, and so on. And then during this process, if the attacker server has impersonated one of these servers and send a wrong response, so ultimately the client will get a wrong IP address. So the client will visit a bank website, but thinking that it's the correct bank website, but it may not be the correct bank website it's visiting. It could be visiting a fake website, a phishing site, basically. It might look like the same, but it may not be in actual fact. So whatever you enter, your credentials, your passwords, and things like that, usernames, that can be captured. So this is why, especially when you think of cybersecurity in your organization, in your networks, and so on, it is very important to think about the DNS aspect as well, right? Because a lot of people, they may not be considering DNS, in a prioritized way, but it's actually good to include DNS security into your cybersecurity strategy and make sure your DNS is secure, because most of these attacks that can come, because every day you may be using emails and things like that, right? So if your DNS is broken, or if your DNS is being compromised, all these things can go wrong. Your emails can be compromised. Your name servers can be compromised. So there are various abuses can happen if you do not give enough priority for your DNS infrastructure, because DNS is a public facing infrastructure. That is why many attacks can come through that. So from this perspective, we have to think about DNSSEC. So DNSSEC stands for Domain Name Security, Domain Name System Security Extensions, right? DNS security extensions. That's what we mean by DNSSEC. So there are many benefits of DNSSEC. First of all, it adds security to DNS by incorporating public key cryptography. You may have heard about public key cryptography, where you use keys, right? Key-based authentications. So what we are doing here is that we are bringing in the key-based authentications into DNS as well, right? And then whoever the parties who receive this data, DNS data, like the DNS resolvers or the clients, they can validate these responses, right? They can validate these responses and see whether these responses are valid and true, right? So that's what we try to do this. And then this would help preventing all those DNS threats and abuses that I was explaining before. So there are many abuses we can stop, things like cache poisoning. Cache poisoning means wrong answers get cached in DNS resolvers, or redirection to fake destinations, because the resolver can, instead of sending your queries to the right authoritative server, like what we explained before, the query can be redirected to a wrong or a fake destination or server, that is the name server that is going to send you the responses, authoritative server, right? So these things can be stopped, right? These things can be prevented by DNSSEC as well, right? So we try to achieve here the authenticity and integrity. These two terms are very important, authenticity and integrity. Authenticity means, are you getting the response from the right server? Okay. So if you ask me a question and if I send you an answer, right? If I send you an answer, you have to know whether I am the right person. I am the expected person to send this response. So if I can somehow prove that I am the right person, that means, we try to achieve the authenticity. Integrity means when you ask the question, I send you a response, and my response is not modified in the middle. So whatever response I'm sending, the integrity of that, the data is not changed, right? DNS data is not changed in the middle. So we try to achieve that as well. One of the important things what you can observe here is that we are not talking about confidentiality factor. Confidentiality means if I send you something, I will send you in such a way that no one can see that in the middle, like encryption, right? So with DNSSEC, we are not talking about encryption, right? So we're not talking about confidentiality factor here. There are other ways. If you want to achieve confidentiality, you have to think about other protocols, okay? But with the DNSSEC, what we try to achieve is the authenticity and integrity. Is it the correct server sending the response? And the data is not modified. That's what we want to make sure, okay? So we try to achieve these with DNSSEC. And then protects your digital integrity, your business, protects your customers online. So that's the critical aspect here, because as I told you earlier, DNS is a public database, or whatever the information, what you have in DNS is public. So so that is why actually here we are not talking about encryption and things like that, because it's all public stuff, right? So what we want to make sure is whether it's coming from the right source and the data is not modified in the middle. Okay. All right. So this also can be complementary to technologies like SSL or the certificates that you use at the moment, right? So DNSSEC will provide an extra layer of security. So it will complement the technologies like SSL, right? So you can secure the web communications as well. Okay, so these are some of the benefits that you can achieve using DNSSEC. Now, so if you remember the same DNS query process that what we discussed, and after adding the DNSSEC, or as an extra layer, after adding the DNSSEC or security layer, so basically all these responses that you are getting from the root servers, the TLD servers, the second level servers, and so on, they are protected now, right? So all these queries and the responses that is received by the recursive name server or the caching name servers or the resolvers can be validated, okay? So that's the key about DNSSEC, right? So that is how the DNS security gets operational. So there are two aspects of DNSSEC when you think of the working aspects, right? So there are two things. One is signing the zones, right? Or say, for example, if your organization has a domain, your own domain, I think I'm sure, like if you're a business entity or any organization, you might be having a domain name, right? So this domain name may be under .com or maybe under .mm with a second level domain, right? Or a third level domain. So if you have that namespace, what you have to do is, if you're managing the authoritative name service, you have to digitally sign that data within that zone or within that domain, okay? And so if you are a domain administrator, you have to generate the cryptographic keys, right? You have to generate those private keys, public keys, and so on, and then generate the signatures, and then you have to do basically, all those records associated with your zone are cryptographically signed. So the resolvers, when they receive this DNS data, they can verify that. So if you are a registrant, that means if you are a domain name holder, your task is to sign your domain. That's very important. And the other aspect is, if you are a DNS operator, or if you are ISP, if you are a mobile operator, if you are a hosting provider, and so on, right? You have to do DNSSEC validation. So you need to activate that because you are running resolvers. Remember, what are we trying to achieve by activating DNSSEC validation? That would verify the authenticity and integrity of DNS responses, as I explained in the previous slide. So we try to achieve the authenticity. That means whether we are getting these responses from the right servers, and the integrity, that means these responses are not modified in the middle, okay? So this may need some configuration changes, which are quite simple. And then sysadmins, DNS admins, and so on, they can actually turn on the validation, DNSSEC validation function within your resolvers or the recursive servers. So here we are talking about two aspects, right? So those are the two aspects. One is the signing, and then the other one is the DNSSEC validation. So in a summary, who should implement then DNSSEC? So we will try to actually have different industry, operators, segments, and so on. If you, because, today there might be, there might be participants from different type of organizations. So if you are a registry operator, if you are running a registry, say if you are from .mm registry, right? If you are from .mm registry, you have to deploy DNSSEC definitely, because you are running authoritative name servers for .mm or second levels of .mm, like net.mm or org.mm, or these kind of second level domains. If you are operating those, you have to sign your zones. If you are a company, or if you are a business entity, say you are a bank, or say you are a university, or say you are a enterprise level organization, what you have to do, you have to sign your domains, because you have got your own domain, you need to get them signed. Sometimes some organizations may have outsourced the DNS operation to another third party, right? You may not be the one who is handling the DNS operations. But if you have outsourced your DNS operations to another party, you have to actually work with them and make sure they help you to sign your domain, right? So the bottom line is that your domain has to be signed. Your namespace has to be signed. The data has to be signed, digitally signed. And then remember we talked about two things, right? One is the signing, and then the other thing is activating DNSSEC validation. Because some organizations, some companies, some business entities, you are running your own resolvers. You are running your own recursive resolvers. So if you're running your own recursive resolvers for your own users within your organization, you should activate DNSSEC validation in those, right? So if you're a company or a business entity, make sure that you do these two functions: sign your domains, and then activate the DNSSEC validation. Also, as I said before, if you have outsourced your DNS operations to someone else, to another third party, work with them and tell your requirements that we want to sign our domain. We want to actually activate DNSSEC in our resolvers. So ask them to do that for you, okay? So that's if you are a organization, company, business entity, and so on. And if you are ISP, or if you are a mobile operator, if you are a hosting provider, because some of you today who are attending this session could be ISPs, could be mobile operators, could be hosting providers, and so on. So what you need to do, you have to activate DNSSEC validation, because your main function here is running resolvers for your clients. If you are ISP, you are running resolvers for your customers, right? Residential customers, and so on. If you are a mobile operator, you are running resolvers for your mobile clients, right? Same with the hosting providers. If you are providing hosting, you could be providing them the resolver service. So in such situation, you have to activate DNSSEC validation in your recursive resolvers, okay? Also, you could be running your own domain, right? So if you're running your own domain, you have to sign your domain, okay? You have to sign your zone. And also, if you are a hosting provider, you could be hosting many hosting sites for your customers. So if you're hosting so many websites, so many domains, make sure that you help them to sign those. Okay, that's your responsibility. And then accept DNSSEC records, such as DS. Let's try to understand about this. Now, I told you before that DNS is a hierarchical system or a database, right? Top of the hierarchy, we have root, then we have top level domains, then we have second level domains, and so on. So if you are an organization, you have to propagate the trust, right? Because this is a hierarchical database. So I say, for example, I am example.mm. right? If I have a domain called example.mm, if I have to sign my domain, that is example.mm, after signing, I have to propagate that trust to my parent, which is .mn, right? So this propagation of trust is done by a record in DNS called DS record. So that's what here we stands for DS. DS is delegation signer. So this delegation signer record has to be sent to your parent. So if you are example.mm, you send DS record or delegation signer record to your parent, which is .mm. And .mm will put that record into their zone and sign with their, they will include their signatures into that. And they will also have a DS record, which they will send it to their parent, which is root, because above them, above .mm, it is the root, right? So this is how we propagate the trust from one level to another level to another level. Okay. So that's how DNSSEC works. Okay, because DNS is a hierarchical hierarchical database. So if you are a hosting provider and so on, if you're running websites for other organizations and so on, make sure that you have signed and send the DS record to the registry, okay, or the registrars. And if you are a registrant, so if you just buy your own domain, you sign your own domain, or you ask if it is another third party is doing for you, you tell them to sign it for you. Okay. So here we have now covered pretty much every industry segments. If you are from a registry operator, if you are from a business entity, if you are from a company, or if you are ISP, mobile operator, hosting providers, if you are from a registrant, if you are just organized, if you are just the individual user who is having your own domain. So whatever the case, you have some part to play. Okay. So if you can act on that, then we can secure the DNS, and we can actually avoid all those risks, abuses that we discussed earlier, things like phishing sites, cache poisoning, and all those kind of different threats that we have. Okay, now let us try to focus a little bit on DNSSEC signing. Okay, this is the technical high-level overview. So if you want to do that signing part, what are the things that you need to consider? First of all, you need to do a little bit of audit and see what is your existing DNS infrastructure, right? If you are running, whether you are running it or some third party is running it, how is your infrastructure, right? And then where are your name servers? And whether your zones are signed, things like that. So, and then you can prepare a plan and get prepared to signing your zone, okay? So if you are from example.mm, you can start thinking about signing example.mm. And make sure if you have, say, few name servers serving example.mm, you have to make sure all those name servers are also capable of DNSSEC signing, okay? And then if it is third parties involved, registrars involved, because sometimes you could be just buying your own domain from a third party or a registrar, okay, or a reseller. So discuss with them, right? Tell your requirement that you want to sign it, and so you can get their help. If there are registrars or third parties who are not really supporting DNSSEC, if they are not helping you to sign DNSSEC, then it is your choice whether to stick with them or go to another provider or a registrar or a reseller who can provide DNSSEC signing. Okay. Think about software solutions as well, because if depending on your situation, if it's a very simple operation, you can do this even manually. But if it is bit complicated if you have many zones, or if you have some regular key generations, because I told you that we have to do key generations, right? Key management and things like that. You may have to go for some automated solutions as well. Okay. So you need to think about those aspects as well, what software that you may have to work with. So generation of DNSSEC keys, this is also something that you may have to work it out. Now, first of all, these keys, they would never expire, right? If you think of cryptographically, if you think about keys, keys would never expire. But it would be a good practice, even though the keys would not expire, it would be a good practice to change the keys time to time. Similar to our password policies, right? Remember, like you can use your password for a long time, but it is a good practice that you change your passwords time to time, right? So that any attackers, miscreants, and so on, they cannot do reverse engineering and generate your, crack your passwords, right? So in the same theory, even when you use DNSSEC keys, it is a good practice that you change those keys time to time. You generate and regenerate. This is what we call key rollovers, right? Key rollovers. So we do that as a good practice. And then you have to do your testing. So you need to have some testing infrastructure before you go on production, and make sure that you have enough resources. Your processors can process these, because, once the zones are signed, especially, it will take some resources, right? Because now all those DNS transactions will have signatures associated. So if you're ISP, if you're a mobile operator running your recursive resolvers, they have to do DNSSEC validations, which means, they have to compare these hashes. So it would take some resourcing as well. So this is why it's good to run this in a test environment first and see, see whether your resources are enough. Okay. So that is before going into production. And after that, if you're comfortable with everything, you can go into production. And then when comfortable, when it's all running properly, you can upload the DS records. Remember, we were talking about propagation of the trust to your parent level. Okay. So that can be done, right? Once you propagate the trust to your parent, then it goes through the DNS hierarchy and all the way, the full hierarchy is getting secured, right? That's when you can say that, the DNA, based on your domain, based on your zone, it's now properly secured. Refresh the signatures. Now, when you think of the signatures, earlier I told you that the DNSSEC keys, that those keys will not get expired, but the signatures do, because we are talking about signatures here, right? Signatures have expiry, so you have to actually manage the signature expiries. This is why I was telling you before, if you have a small zone, if you're having small amount of DNS data, you can still manage it manually, right? Because you know when the signature is going to expire and things like that. But if you have many zones, if you're running zones for your customers, if you're running many zones to your customers and so on, then you have to have some key management tool. You have to have some proper software to do the key management part. Okay. So this is why, doing this in a test environment first would always be beneficial. And then apply the best practices, right? But there are a number of best practices when it comes to DNS, right? DNS security and so on. So it is always a good practice that you should think about those. Update your business continuity plans, right? Once you have done these things, you can now bring this into your business continuity plan. Because, say, for example, I told you earlier that your DNS can go wrong very often, right? DNS can get attacked, DNS can get abused. If your DNS is compromised, many other things can get compromised as well, like your email and so on, right? So this is why you should always include DNS into your business continuity plan, okay? So you can update now. Once this is done, you can update there as well. And then the next step would be, keep monitoring, right? Keep monitoring, analyzing, improving, implementing, and then further monitoring. So this goes on and on as a cycle, okay? So that's how you bring in the DNSSEC signing into your cybersecurity strategy as well, okay? So these are some steps that you can think of. And finally, I also want to give you some stats so you can understand, how the other countries, the world is doing on these. Now, if you think of all the top level domains, currently there are around 1,400 over 1,400 top level domains in the world. So when I say top level domains, these are like .coms, .net, .edu, .coffee, cities, and there are many top level domains now, right? So out of the, including .mm, okay, because .mm is a country code top level domain, but still it is a top level domain. So out of all that in the world, 1,341, so which is coming to around over 90%, has deployed DNSSEC. So all these green area, they have deployed DNSSEC when you're talking from a top levels perspective. And then the red part, that's where the TLDs that has not deployed DNSSEC or that have not signed their top level domains. But now, and when you think of top level domains, there are different categories as well. There are things called generic top level domains. Then there are things called country code top level domains. Now, these generic top level domains, including the new generic top level domains, they have to sign a contract with ICANN and how they operate their generic top level domain, right? So in this contract, because they are contracted parties, so in this contract, deploying DNSSEC is a requirement. So all the top level domains, the generic ones, are in the green area in this pie chart, okay? Because they have to do it, they should do it. But the country code top level domains, they don't have contracts with ICANN because they are sovereign countries and so on. So ICANN would not enforce policies towards those. So if you think of, say, .mm, for example, they don't have a contract with ICANN. So they have a choice whether to deploy DNSSEC or not. But most of the CCTLDs, they have deployed DNSSEC as well because it's a good practice. But still, some CCTLDs in the world, they are still in the process of deploying DNSSEC. That's why there is some certain red part here, okay? So around 6% or so, they have not yet deployed DNSSEC, okay? But they are working on it, and we see improvements with the time. We see these figures are improving, and we hope to see some, further improvements in these percentages. Okay, so that's the situation with top level domains. Now with CCTLDs, you can see currently there are 309 CCTLDs in the world, like .mm for Myanmar, or .th for Thailand, or .sg for Singapore, and so on, right? So if you think of the CCTLDs, out of 309, 202 has fully deployed DNSSEC. There are some partial, currently working on. And then red area, 93, still they have not deployed DNSSEC. So almost like 30% of the CCTLDs in the world, they have not signed their zones yet. But you don't have to actually, from Myanmar's perspective, this is really not applicable because I want to actually show the situation in Myanmar. .mm CCTLD has signed their zone, right? They have signed their zone. You can see the DNS keys, right? DNS keys. Now, this DNS key resource record is published when you publish your public keys into the DNS. Okay, remember we talked about keys earlier. So when .mm has published their keys and signed the zone, that means anything under .mm. So there are currently we have 7 second level domains under .mm, biz.mm, com.mm, edu.mm, gov.mm, net.mm, org.mm, per.mm. So all these second level domains, they have also signed, which is very good. Because when I further dig into details, I see that all these, including MM and all these second level domains, they have the same name servers, right? They have the same. So when you are using the same name servers, it is quite easy for you to actually sign all these domains. So that's what they're doing. That's what we have found. So in Myanmar's case, .mm, the same the same name servers that are running with .mm are also running the second level domains of all these. So they have signed, which is good, right? Which is really good. And also DNS key. They have all published the keys into the DNS. Also, importantly, they have propagated the DS records to their parent. Remember, we talked about delegation signer record. So all these second level domains, they have propagated the DS records to .mm. And .mm has propagated the DS records to the root. So if you see the root zone, you see the .mm DS record. Okay. So from .mm's perspective, it is very good, actually, because you have deployed DNSSEC. Now, the question is, if your organization has a domain within, say, .com.mm, say, example.com.mm, if your domain is example.com.mm, or if your organization domain is example.net.mm, say, if you take mmnog, I see that mmnog domain is mmnog.net.mm, right? So it is worthwhile to see whether mmnog.net.mm would sign. If you want to sign, then you have to delegate or propagate the DS records to net.mm. It is possible because they have signed. They can accept your DS record and then pass their DS records to MM, and MM would pass their DS record to the root. Okay. So that's how it is the situation with the Myanmar, okay, in terms of signing. I have also included some stats with the ROAS. ROAS are, the route origin authentications. So these are more related to the addresses, because all these name servers that I was talking about that are serving these domains, they are in a certain IP block, right? Whether that IP block has a ROA, right? You should also consider, I mean, it's pretty good because in case if it is related to the Myanmar, about 96% of those, they have ROA, except only one of the name servers in these .mm and all these second level domains, one of the name servers, that IP block did not have a ROA. That's why the small percentage of 4% was gone. Other than that, 96% is having ROAS. Okay, so that should be fine as well. Now, one of the thing I also observed was there are no IPv6 addresses for these name servers, right? Earlier presentation from AP Nick actually showed the importance of IPv6 and so on. So it is also equally, I think, especially, the MM registry can think of running these name servers with IPv6 addresses as well. That's something to think about. All right. Now I also have a little bit of, before, winding up, just have some updates, some statistics, some measurements on the keys. Remember, we talked about keys. Now, these keys, there are two types of keys. One is called the key signing key, and the other one is called the zone signing key. So we use the zone signing key to sign our zone, and then we propagate. Remember the DS record that we talked about? That is the hash of this key signing key that we send it to our parent. So when you think of Myanmar.mm has started generating these key signing keys and zone signing keys since 2011, right? So you could see that U.mm has been having, in fact, I have also been working with them for quite long, since 2011 as well. If you, I don't know if there are, those days it was run by MPT, the Myanmar Post and Telecom. So those days we started generating the keys for .mm. So that's the time period. You can see there were active zone signing keys and key signing keys. There was a small time period where the DNSSEC keys were not generated, somewhere around 2020. But then since after a few months, 2021, we could still see the active keys. So even as of today, you have .mm has active zone signing keys and active key signing keys, right? So you could see that. These are all the algorithms that you are using to sign these keys. You're using RSA SHA-256. That's the algorithm with 1024 bits for zone signing key and 2048 bits for the key signing key, which is also okay. There are some new algorithms you can think of, like some newer algorithms, but for the time being, I think this should be okay. You could be worried if you're running SHA-1, right? Because SHA-1 is deprecated and outdated. You're running SHA-256, which is fine from a security point of view. Next thing, I think I have also updated earlier about DNSSEC validation. So DNSSEC validation is done at the recursive server level, right? Recursive server level. So whatever the responses that the recursive server get from the authoritative name servers are compared against the signatures. So here what we're doing is we're comparing the hashes. If the hashes are not matching, the answers are not sent to the client, okay? So if the client is not getting the answer, client would not go to a wrong website or a phishing website and so on. So that's the validation process. So I told you who should be doing this: ISPs, mobile operators, and so on. If you are running some recursive servers, caching servers, resolvers, you should be doing this. What do you need to enable DNSSEC validation? Basically, if you're running your own recursive name servers, it's a very simple configuration process, right? This doesn't include any extra investments or buying new servers and things. You don't need to do all that. It is just a matter of activating enable DNSSEC validation in your configuration, and make sure you allow things like you have a trust anchor to the root so that the validation process can happen. You open the TCP port 53 for DNS traffic, EDNS 0 for larger packets, because when DNSSEC is enabled, packets will be much larger because those packets includes the signatures as well. So those are a few little things you may have to consider. Okay. And if you're not familiar with these things, of course, you can talk to your sysadmin or administrators, or even talk to us if you need some further help. I also want to actually show you some statistics, how Myanmar is doing again in terms of validation. And you can see here the Myanmar is in light green, which is good, right? Compared to many countries in the world, which is in the red or orange zones. Again, these stats are based on APNIC Labs statistics as well. And so in terms of Myanmar, the validation is around 67%, right? So which is quite good, actually, right? because many of the operators in Myanmar, they are doing validations. So that's why the average goes on to something like 67% or kind of light green here. If you can get into sort of dark green range, I think that would be very good. That would go into, 90%, over 90% or so. This is again, in terms of the AS numbers, the networks who are doing the DNSSEC validations. You can see some of the providers in Myanmar, they are having very high percentage of DNSSEC validation, over 90% or so, right? You can see against the AS numbers, the operators. But some operators, they are not doing DNSSEC validation, so that's why it's showing 0. That's why it averages up to around 67 in general. Some they are doing 20s, 30s, and so on. Some doing 80s, 90s. So these are the ones, right? There are a fair bit of operators, ACE numbers, who are actually not validating those resolvers inside these networks. They're not doing DNSSEC validation. Maybe if you are from any of these operators who are having 0 validations, you can think about enabling DNSSEC validation, right? So maybe after this session, when you go back, talk to your DNS administrators. If it has been outsourced, talk to them and see whether if you can activate DNSSEC validation so that we can bring the percentage in Myanmar even further higher. Okay, I think that's what I wanted to actually talk to you. And in case if you're not familiar of doing this, you can talk to your subject matter experts, or you can be in touch with us, ICANN, and other parties who are offering a lot of capacity building, training, and things like that in relation to DNSSEC. With this, I will wind up my presentation. If you have some questions or anything, I can take it now. Thank you.
Thank you, Mr. Champika. Questions, please? Question? MDG? You are running DNS. I think no question.
Okay.
Now,
yes, thank you very much. And it's very nice talking to you all today. And let's keep in touch.
So sorry, please. One question, I think.
Okay.
Hello, Mr. Champika. I would like to know about the expire of registered signature. What is the best practice of any suggestion from your side?
Can you repeat the question again? I missed some of the parts.
As your explanations, a key cannot be expired, but the signature can expire. Is that right?
Yes, that's right. That's correct. The keys do not expire, but the signatures do have an expiry. So if you are managing your DNS keys, you can still continue to have the same key. You could see even when I show the statistics, maybe I can go back to Myanmar keys, right? So you could see that you were running the same key. This is the key ID, right? So you can see key ID 14581 here, and then there is a key ID here as well. So you were running this key, same key from 2011 until 2020. So it has not been changed for all that time. So you could use the same key, that is okay. So keys would not expire, but you could still change the key as a good practice. So after that, you could see that now in 2021, you have gone to a different key, you have done a key rollover, and you have a new key now. So it's a good practice to change the keys. But signatures, you cannot do it for several years like this. Signatures have expiry. Okay, so signatures you have to keep monitoring and do the changes.
Okay, so we should be monitor for signature expired.
Yes, correct. You have to, if you are doing manually, if you are doing the signing manually, you have to keep a record manually, and then you have to have an understanding of when your signature is going to expire for those appropriate records. But if you are doing some, say in some of the name server softwares, they have actually built-in mechanisms to automatically monitor that process as well. Or if you're using some automated softwares, for key management, that would help you with you don't have to remember all those things. The software will take over and do the re-signing based on the before the expiry happens.
Okay, we should the best do for monitoring for detection about the signature expired. Is that right?
Yes, you have to keep an eye. Bottom line is that you have to keep an eye on the signature expiry, because if the signatures get expired, then the resolver will think that it is an invalid record. So the answer will not be given to the client, and client will not be able to visit the website or go to the required place.
Okay, thanks for your explanation.
Thank you.
Thanks, Mr. Champika. We will start for quiz session.
Okay, thank you. I will stop my sharing.
Thank you. Quiz session စနေတော့တစ်ခုမေးမယ် Mr. Champika ကိုအခုမှမဟုတ်အခုအတန်းတက်မှမဟုတ်ပဲနဲ့အရင်သိရလူပဲနှစ်ယောက်ရှိတယ်လက်ထောင်မှာကြည့်လားဆရာနိုင်မသိဘူးလားဟုတ်ပြီ